In this video, we're going to review some of the material for Lab 3. First, let's take a look at some of the things we did in the lecture. We did a regular 4-bar analysis and worked through calculating V sub A. If we know this length, the length of this length, then we know that omega 2 is 10 radians per second. We can get that velocity. Because the velocity of point A is traveling in this direction, we can figure out the instantaneous center for the coupler because it's connected at that point, so it has to have the same velocity at that point. And the instantaneous center has to lie along a line perpendicular to the velocity. The same thing with point B, which is connected to link 4, which is pivoting right here. So its velocity has to be in that direction. That allows us to just, with a little bit of trigonometry, figure out the instantaneous center. And then we were able to, knowing the velocity here, we were able then to calculate omega 3 and so on, work our way around, calculate V sub B. Once we have V sub B, we can calculate omega 4. And then, of course, we can find velocity of any point on the coupler by just measuring from the instantaneous center. In the next slide, we have a slider crank mechanism, and we have to determine the velocities of the slider and the x and y coordinates here for the coupler. So anyways, on this particular one, we can use these equations to calculate for the slider. We can get theta 3 in D, which is the same as R1 right here. So if we go ahead and use these equations, of course we get two possible angles in the solution for this. We want the 153, right, measured from the positive x-axis over to this link right here. And we also calculate D. And of course, the numbers, you might be wondering why I use kind of strange numbers here, 1.414 and so on. Well, we come up with a nice answer for D here, which is 5, which of course means the location of the instantaneous center. Well, we know that the velocity of the crank right here, that the instantaneous center has to be perpendicular to the direction of that velocity. The slider is moving in this direction, so this kind of simplifies the problem. It's just at 45 degrees up here. And then we can go ahead and calculate V sub A, knowing that angle, and omega 3, which is the angular velocity of the coupler. And once we have that, we can get V sub B because once we know omega 3. So let's take a look at solving this problem with the Norton linkage software. So in this problem, just we did get a velocity V sub A of 14.14, V sub B was 15, and omega 3 was 2.5. So I have this set up. We put the same values in. The offset, of course, is -1 for this case. So here's the linkage. And then if we go ahead and look at the values here, and let's say we want to find velocity of the slider. Okay, so here, this is a bug in this software. Sometimes when you go to something like here, velocity in the x direction -14, velocity in the y, it says -14, magnitude -14. That can't be true, right? In other words, if you use the Pythagorean theorem, the square of this plus the square of that, you add them together, take the square root, you got to get something bigger than 14.997. So the trick is just go back and start with the thetas, okay? And then it recalculates, and so now if I go to the velocity of the slider, there you can see the magnitude is 15, it's going to the left. And if we want the thetas, so theta 3, so theta 3 here turns out to be 153.